Okay.
During the live stream, and you can give me a mic so I can breathe into it the whole time.
That could happen. You never know. Could be exciting. All right. 5(3), number 2. Pi over 4 plus 2n pi, and 3 pi over 4 plus 2n pi, and 5 pi over 4 plus 2n pi, and 7 pi over 4 plus 2n pi. Number 4 is pi over 4 plus n pi. Number 6 is 2 pi over 3 plus 2n pi, and 4 pi over 3 plus 2n pi. Number 8 is pi over 3 plus 2n pi, and 2 pi over 3 plus 2n pi, and 4 pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. Number 10 is pi over 2 plus 2n pi, and 3 pi over 2 plus 2n pi. And number 12 is pi over 6 plus 2n pi, and 11 pi over 6 plus 2n pi. What questions do you have on those?
I didn't do them because I don't really have an excuse, but I had 3 weeks. But I woke up
So
this morning.
you didn't do them. Okay, great. So you don't have any questions?
No, I do not
Great.
have any questions.
Let's move on with this lesson. This is still in 5(3).
Yes. I'll do them whenever I get home today.
So the instructions on these, this is the same sort of thing, but the instructions are slightly different. The instructions say find all solutions of each equation on the interval 0 to 2 pi, including 0, not including 2 pi. So it's the same thing, but instead of doing the plus 2n pi and all those things, you just list the solutions, right? Because it's constraining the domain. So let's do a couple of examples and then a couple more, and we'll see from there. So we've got 2 times sine x cosine x equals the square root of 2 cosine x. Okay. Let's ask you what you think we do and see whether you're going to make a mistake that'll poof away answers or not. What do you think we do? Because there is an easy mistake to make on this problem, and it'll give you if you make the mistake, you'll get some of the answers right, but you won't have all of the answers. Don't look back at your notes, look at that thing and think about, there's no identities you can use. That's a good thought. Good thought to be thinking about identities, but there are not any identities that will save you.
It's already in sines and cosines and all that junk.
Yep. We're just solving for x.
Well, what I would do is I would just like subtract the cosine x and from, I guess we could do that because they're multiplied.
So what you mean is you would divide by cosine x,
Yes.
which is the mistake. If you just divide by cosine x, you're going to miss some of the answers because cosine doesn't just, because then the cosine's going to poof away and it can't poof away. So what can we do instead of dividing by cosine x?
Well, we only have one sine, so we could just like.
How about we get everything on one side?
I guess
What could we do to do that?
5, 3, continue. Notes. Oh, notes. Where are the notes? That makes sense.
This is guided practice 3A at the bottom of page 328 in case you are curious where this came from and what the instructions are.
Where's Reese?
Dying in the bathroom. Or he may have left, I don't know.
He's already left. I have a feeling that the car may have hit because there's a lot of.
Anyway, so if we want to get everything on one side, what can we do?
Subtract.
Subtract what?
Square root of 2 cosine x.
Yeah. When we subtract square root of 2 cosine x, we end up with 2 sine x cosine x minus square root of 2 cosine x equals 0. I said 3a. Guided practice 3a.
3A on 328.
Okay. Now what could we do?
Any number of things. Hold on.
What do both of those terms have?
Cosine
No.
X.
They both have a cosine x, so what can we do with it?
We factor out a cosine.
We could factor out a cosine x. That's right.
And then you don't proof for cosine X.
That's
So you
right.
can see the thought process.
Now what could we do? It's factored and equal to 0. What can we do?
What's it called? I don't remember the word.
Set
Set.
each.
Oh, set each one equal to 0.
Set each factor equal to 0.
I was like, what? Cosine X equals 0, and then 2 sine X minus square root of 2. Is there a tissue box in here? Absolutely.
Apparently not. Sorry,
Cooked.
you're cooked.
2 tissues.
All right, so now what?
Because we don't have any tissues. Divide by x on cosine x. Wait, no, that wouldn't.
That x isn't multiplied. That doesn't even make sense. This one's ready to go, ready to spit out some answers. This one's not.
Add square root of 2.
And then divide by 2. I agree. Sine x equals the square root of 2 over 2. Great. Now what?
Oh. Calculator?
No.
Calculator.
This is a no calculator there bit, yeah?
Oh, wait, it's 45 degrees, which is, divided by 5
Pi over 4. Where is it positive?
The first 2 quadrants, quadrant 1 and 1.
Okay. So is it pi over 4 and where else?
Pi over 4 and 3 pi over 4.
3 pi over 4. What about this one? Where's cosine of x equal to 0?
Cosine. I'm still writing stuff down.
Sometime this century, where is cosine x equal to 0? You know it's going to be 0 or pi over 2 or pi or 3 pi over 2 or 2 pi. It's one of those, right?
What was the question?
Where is cosine x equal to 0?
Cosine of x equals 0. It's at 0 degrees. Or
Nope.
2, wait, is it? Oh, at 0. It's 90
90 degrees, which is what? In radians.
It's pi over 4.
No, that's 45 degrees.
Over 2.
Pi over 2.
Oh, yeah, because they...
Where else is it equal to 0?
I think that's it.
That's a lie.
No? Is it 3 pi over 2?
Yeah. Because 0 over -1 is still 0, yeah?
It's true.
It's true. It's true. 3 pi over 2. Now, our answer, we're on these problems, we're just listening it between 0 and pi, so we don't need the plus 2 pi in and all that crap. So we just need, I just like to list this in numerical order and then circle it and move on with our life, right? So pi over 4, pi over 2, 3 pi over 4, and 3 pi over 2. There, we did it.
Fun numbers.
Right? Easy peasy. Let's do another one.
3B?
Yep.
3B looks
We are going to do 3B.
just like a more annoying version.
We don't always do both of the guided practices, but we will. In fact, on 3B, we're going to do it fully as a guided practice. So I'm not going to write anything, and I'm going to give you a chance to write and figure it out. And then I'll start writing after that, and we can compare notes.
Yay.
Yeah. 3b or not 3b? Oh, wait. That's not right.
You just dictated out everything for me to write out. You're welcome. Yes, I see the plan.
He sees the plan. He thinks he sees the plan.
Yeah, I probably don't actually, but you pretend like I do.
Boom, 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 ba-da-da-da-da.
I don't see the plan anymore. I lost the plan.
He lost it. Sometimes, remember on some of these trig problems, you just got to start doing stuff and YOLO and hope for the best. But don't poof stuff, because poofing will disappear answers.
That's true. Good stuff. I got the first step right. The easiest step.
Oh, I don't. What I'm looking at is I don't have a step-by-step key. All I have is the answer. So I don't know that this is the best way. So just because you did what I did doesn't mean that you did the best way. All it means is you had the same first thought as I had. That's some crazy pre-cal nonsense if I ever saw it. If the Algebra 1 students were to see that when we first learned factoring, they might like crap themselves. Because that's some nonsense. But it seems to work to me. Does it seem to work to you?
Just not what I did, but.
Oh, what did you do?
I factored out.
That won't work because you're not going to have 0 on the other side.
Oh.
In order to split it into 2, you've got to have 0 on the other side.
It just literally, okay.
Yeah.
I tried that path, but then I was like, oh yeah.
No, you have to have 0 on the other side in order for factoring to be useful.
Oh crap. I'll do it all over. Okay. Do it again.
What? What are you talking about?
Who, me? Oh, I thought I didn't understand what was happening, but then I realized you literally just added the square root of 2 and then divided by 2. And then you got square root of 2 over 2.
Oh, yeah. Yeah, I said each factor equal to 0. Yes. But I did that.
Simple math, and I was like, what's happening?
Yeah, no. Yeah, that's good. I'm glad you caught up. Good job. That's good process.
What the heck was... Sounds like death was going on in the other room.
Pi over 3. So pi over 3, so that's 3 pi over 3 minus pi over 3, so that's what? 2 pi over 3, right? And plus, so 4 pi over 3.
Is Reese still in the bathroom?
No, he left. I saw him calling somebody and leaving. He was in there with the lights off. I don't know if he gets migraines or anything else, but that could have been it. I don't know. He didn't say. He just looked like he was dying. Not literally, or else I would have, called somebody.
Figuratively dying.
Right? So this one is the ones in quadrant 1 and quadrant 4, and this one will be ones in quadrant 2 and quadrant 3, right? Because this one's positive and that one's negative, right? So it'll be pi over 4, 2 pi over 3, 4 pi over 3, and 7 pi over 4, right?
This just looks like nonsense. But it does make sense.
Does it?
Mostly nonsense. It's, like if, I guess he already said it, but if any Precalculus or Algebra 2 students saw this, they would just cry.
They didn't write it in numerical order. That kind of annoys me.
So what's the square root of the square root of 2?
What? Square root of 2 over 2. What are you asking?
The square root of the square root of 2.
Square root of the square root of 2 would be the 4th root of 2. You thought you got me.
2 times 2 equals 4.
Okay, let's do another example together.
Don't erase it yet. Why is your pen tied to your... It's gone. It's disappearing slowly.
Yeah.
He's doing it slowly so you have a chance. I'm just trying to figure it out.
Do you understand? Do you have a question over part of it?
I don't know. It's the working through the factoring of it in my head. It's just trying to make it compute. Like make it, because I know factoring. I know how it works. I'm just trying to connect the dots.
Well, you've gotten used to just kind of doing stuff in your head, right? And so it's this one, you can do that, but it's easier. That's why I went ahead and drew. Pre-cal, I don't usually even draw the smiley face, but this time I did because it's easier on this one to just think it out mechanically, right? Plus 2 minus square root of 2 cosine x minus square root of 2, right? That's where we started.
Yeah.
Right, so in the first slot, it's 2 things to multiply to get the first term. 2 cosine times 2 cosine gives you that, right? Last slot, 2 things to multiply to get this. I dealt with the signs in a minute, right? So square root of 2 times 1 is square root of 2, right? Then we do the smiley face. Square root of 2 times 2 is 2 times the square root of 2. 1 times 2 is 2, and we're trying to get the middle one. So plus 2 and minus 2 times the square root of 2. Follow our mouth and follow our nose, and there it is.
Okay.
It's the same thing we've always done. You've just gotten used to being, oh yeah, it's this, because you can see all of the things in your head, but this has got, yeah, so it's harder to just be like, oh yeah, it's this. So you kind of got to go back to looking at it mechanically, and just like we started out doing. Fun, 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 till Daddy took the T-bird away.
My dad actually had a Thunderbird.
Did he?
Yeah.
What about a Thunder Cougar Falconbird? If you never watched Futurama, you don't know what the heck I'm talking about.
Never watched it.
Yeah.
I watched it at one point, but that was like when I was 5.
It's pretty funny. That episode is very silly. They're going to buy a car because Amy makes the joke that my parents said if I get all B's, they'll buy me a bar, and I got all C's. So they go get a car and whatever. But then at the car dealership, the dealer guy is telling Fry that he needs to get he sees that he's noticed the Thunder Cougar Falconbird, and Fry's like, I don't know. And he's like, well, it's great that you're not worried that people question your sexuality. It's like, I care, I just can't figure out how to get them to stop. Anyway, it's funny. All right, let's do another one. One with more things. You totally need more things. All you're doing right now is like working at a golf course.
I worked 85 hours last week.
That's great. I'm glad for you. I'm not saying that at this point in your life it's a bad thing, but if all you ever do the rest of your life is that one thing, I'm concerned.
Yes.
It's a great thing for now. You're doing great. Keep up the good work. Just don't only do that. Okay.
Okay.
What should we do?
Go. No.
Eventually. We have kind of a problem on this one, right? What's the problem?
The whole thing.
No, stop lying.
Well, it's not cosine and cosine.
Yeah, that's it. That's it. That's exactly the problem. We've got two different trig functions. So it's going to make it difficult to solve it because we can't factor out stuff because they're different. But we could make one of them into the other one. How could we do that? What identity are we using?
The Pythagorean method.
Pythagorean identity. Which one?
The one that makes the sign.
This is one that really should be in your head already. If it's not, then I would suggest making some flashcards or something.
Sine squared plus cosine squared equals 1.
Sine squared plus cosine squared equals 1. That's true.
A little sheet at home today.
You don't need the sheet. This one should be in your head. Sine squared plus cosine squared equals 1. That one should be in your flipping brain and your regular brain too. Okay. Sine squared plus cosine squared equals 1. So what could this turn into?
That's 2 times, what is it? Sine squared. 1 minus cosine squared. Oh, yeah. And then we explode because we don't know what to do next.
No, don't explode.
We distribute the 2.
Sure. Distribute the 2's fine. Why not? Distribute the 2. We get 1 minus cosine x equals 2 minus 2 cosine squared x. Then what? Then we move it all to one side. Sounds great. So we get 2 cosine squared x minus cosine x minus 1 equals 0.
Then we can factor it.
Then we can factor it.
We got
2 cosine, 1 cosine, 1 and 1. Minus and plus, right? because we want it to be negative, so the 2 needs to be negative.
Yep. Yep.
So the cosine of x equals negative 1/2 and 1. Get the same sort of arrangement, right? For the positive, we've got 1. Where is cosine 1?
I'm writing stuff down because I forgot. Landon's on a call for work or something.
So the instructions are the same as before, so we're finding it between the interval 0 to 2 pi, not including 2 pi. So, where is cosine, no, not negative 1. I don't know, I'm looking at 2 different things at once. Where is cosine 1?
1 is, that's 0.
That's 0.
My mom told me to go check and see if Reese was alive. Because his mom told her to tell me to say that. He does have a migraine. He's like dead in the back of his car.
Yeah, I told you. Context clues. I'm no dummy.
Contact. So right. It's right, Landon. What?
Where else is it 1?
At pi, or 1 pi. No?
It's negative 1.
That's negative 1? 2 pi.
Yeah, and we're not including 2 pi, so, right? So
So
that's good.
it's 0.
So where is it negative 1/2? So we're talking about this quadrant and this quadrant, right? Where is it 1/2?
Where is it 1/2? What is it? Cosine, it's 60 degrees.
We're doing radians because we're
With
smart.
radians, which 60 degrees is pi over 3, which is, but it's negative, so it's 2 pi over 3? 2 pi over 3. Isn't it?
What?
It's
No.
pi over 3.
Pi over 3, and then what is it over here?
3 and then
2 pi over
2 pi over 3.
that's what I said.
3. You said negative. You said.
You did say 2 pi over 3, and then you second guessed yourself and moved on to who the heck knows what. But that was the first thing you said, yes.
You were saying a lot of words.
I said, yeah, it was 2 pi over 3, and I was making sure. I was
And
right.
7 pi over 3, right?
Ooh, okay. Is that right?
So there's the answers, right? Easy peasy. So at 0 and at 2 pi over 3 and 7 pi over 3. That's not 7 pi over 3. Why did I write 7 pi over 3? I don't know why I wrote 7 pi over 3, but what is the actual answer?
It's 5 pi over 3, isn't it?
I would say.
Well, it would be 3 pi over 3 plus 1 pi over 3, so 4 pi over 3. Yeah.
Right.
Yeah. So I don't know why I wrote that.
Saw that.
All right, let's do guided. No, you didn't. Let's do let's do guided practice 5B, but this time you do it. Ready? Go.
I don't know where I'm getting my head on.
I'm pretty sure that goes something like it's time to get my money right, isn't it?
Huh?
I don't know. It's a song. Something. I don't know. Something about getting my money right. I don't know.
I think Malcolm is dying.
Beer left at 3.
Not as bad as Reese is dying, but like.
My bathroom wall is toast, so that's great.
Why do I need to know that?
You just need to know.
It's really not.
Yeah, there's a bunch of mold and a bunch of,
I don't need to know this.
you know, great. Which one is it?
5B on page 330.
5B.
Ready to go.
Dang it. Why can't everything just be the same and be happy?
If you flip back the page to the first lesson, Landon, it's got the identities in it. I'm sorry you forgot your cheat sheet, but you know, I did say y'all should memorize those. So, you know, starting doing that post haste is wise.
We don't want another iteration of what happened on the last test.
Agreed. I found a really cool flashcard app. It's called Anki. It's really nice. Anki. It's totally free and it's really awesome.
Honky donkey. I don't know why I'm saying that. But
That's definitely true. I went with turning them to cotangents because it seemed easier.
fair enough.
Because you didn't have to rearrange the identity. That's what I did.
Fair enough.
But you can do what you want as long as it's math legal, right?
Fair enough.
You're a fair enough.
Fair enough.
I'm gonna smack him up.
Fair enough. As a punch. You successfully didn't hurt me, but you hurt yourself.
No, I already hurt myself a while ago.
Yeah, but you
I
hurt
burned
yourself
myself in the
again.
oven last night. That was behind.
Yeah, why did you do that?
I was putting a steak in the oven. And then
Keep going. Focus.
Well, I'm trying to get him to not focus so that I win. This is a challenge. This is a challenge.
If you say so.
Oh wait. 2 cotangent x plus 2.
What?
Math thing out loud.
Okay.
And I did the first part right. And I overcomplicated the second part. Okay, that's great.
Maybe I should distribute. Maybe.
You probably should
I
distribute.
feel like we could factor out some stuff as well.
Not once you move the 2 over.
Oh, what if I don't want to move the 2 over yet? And then I just like go.
Actually, the 2 is going to disappear, isn't it? That's fun.
It is gonna disappear. Holy crap!
Two.
Two.
2 minus 2 is gone.
2 minus 2 is gone.
Now we can factor stuff.
Well, I would combine like terms first. That would probably be smart.
I guess.
I guess.
Did you just do that to?
Holy word.
What's there to be?
These holy words. You know, the holy word of God. Right?
Do 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 do.
This all makes sense.
Now you gotta do the weird quadrant part. I don't like that part.
I feel like I made a mistake, but the key does just have 2 answers, so maybe I didn't make a mistake.
That's what I'm seeing. Huh.
Why does that one go away? Landon?
Because gay.
No, that's wrong.
Why is it square root of 0 and not just 0?
I'm not done. I just asked why the orange one just goes away.
He doesn't want to be here.
Nope. Plus or minus square root of negative 2. What happens?
And that's a good question.
Yeah, but it's a simple question that you know the answer to.
Plus or minus negative 2.
No, I didn't say plus or minus negative 2. I said plus or minus the square root of negative 2.
Negative square root i's.
Yeah, you get i's.
Oh,
So
because it's square root of negative 2. Oh my gosh.
cotangent of 0.
Idiots. Landon,
No, I just think our brains are working on other things.
we forgot about the negative
You
thing.
did too. I at least remembered.
Well,
All right.
weird.
Where is cotangent 0?
You both suck.
No, we suck.
Where is cotangent 0?
We already did this. It's pi over 2
It is pi over 2.
and 3 pi over 2.
Pi over 2 and 3 pi over 2. Accurate.
We already did that stuff.
But with tangent. But yes, same.
Same.
Because 0 over 0 is, well, it depends on the context, but you know. The reciprocal of 0 is 0, right? Right. Well, actually, yeah, no. Anyway, let's do another one.
Okay.
Another 2, and then we'll be done with this part. And then see what we get to, what shenanigans we get up to next.
Shenanigans.
What fun fruit roll-ups will they roll out with next?
Hope he's got a different mug today.
What?
It's new, but it's different.
What?
A mug. So
Okay.
it's on the mug.
Okay.
You're a little.
Secant x plus 1 equals tangent of x. Okay, there's 2 flags on the play. There's 2 problems. What's the 2 problems?
Secant doesn't do tangent.
Not if it's to the first, it doesn't.
Exactly.
So we've got 2 trig functions, and we can't turn one into the other one without some shenanigans.
Revert the kind of sines and cosines?
We could, but let's not do that next. How can I turn tangent into secant?
Well, tangent squared is like secant.
That's true. Tangent squared is
Secant minus 1?
all that stuff, right? So what if I square both sides?
Then we'll have.
Oh, and then we can also just cancel the squares afterwards because secant squared and stuff.
Just square both sides.
We could square the 1, but the 1 becomes 1.
Now what?
Tangent x squared turns into secant squared. Or,
Yeah.
What?
Secant squared minus 1.
Secant squared, yes,
Tangent
yes.
is turned into secant squared minus 1.
yeah, I went backwards and around.
This right here turns into secant squared x minus 1. True enough. Do I want to do anything on the left side? Probably.
Yeah, let's distribute that.
Yeah, by not distribute it.
Or factor.
Not
No,
factor.
not
Unfactor.
Unfactor.
You use the binomial theorem, right? 2a squared minus 2 or plus 2ab plus b squared, right?
2a squared. No, isn't it a squared plus 2ab?
That's what I said. That's literally what I said.
No, you said 2a squared.
No, I didn't.
Definitely didn't say that.
Roll back the tape.
Yeah, please.
We literally do have a tape.
We do have a tape. We will see. That you definitely said 2a
So
squared.
people watching the live stream.
No. Well, maybe.
Now what?
Just combine like terms. Wait, no, you'd have to move.
Well, kind of.
Like, just move things to the right side or the left side.
Yeah.
In this case, I meant right as in like correct. Oh, just
Go
Oh, I thought it was
ahead.
Now what?
Add 2 and then divide by 2, and then get 1.
And 2
Secant x equals 1.
No. You subtract 2 divided by 2 is negative 1.
Yeah.
That is the math that maths.
That is the math that maths.
Where is secant negative 1? Where is cosine negative 1?
Oh, somewhere.
hold on, I'm getting there. Okay, what was the question?
Where is secant of x negative 1?
Cosine of 1, which is
For the zeros and the ones, no, it's not. For the zeros and ones, just think about the picture. I've said this before, but this is sine, right? This is cosine. Cosine makes the U, sideways C looking shape. Negative 1 down there. Where is down there?
let's see. That
0, 2 pi. Pi is right in the middle.
yeah, I'm sorry. It's pi.
It is at pi. Right? So sine, same thing, would be at 3 pi over 2.
Is it 3 pi over 2?
No, it's cosine. It's secant, so it's pi. I'm just saying, for the zeros and the ones, use this instead of the other chart in your head. This is so much easier to think. Yeah? Yeah, this one inside here. Okay. One more on your own GP, and then we're done with this lesson.
And that was before there was level 6, so it's actually good. And now cry.
Yeah, I have level 15. Now, it doesn't even matter. Because of the graphs, it actually have both hero and
6B, ready, go.
hero less. I do have the numbers. Which one?
346B. I think, wait, is it 340?
Ready, go.
What page is it again?
I'm not going to answer that question. When I'm talking out loud, y'all listen and stop talking to each other. Frickin' cows. Not y'all, just the exasperation. You're clearly not a cow. You're not nearly heavy enough.
Thank you. I understand.
It looks so simple, yet it's so devious.
It's so devious, isn't it?
So devious.
Is it?
No, we gotta square this. We definitely gotta square this.
Yeah, definitely. Ready, go.
Square. Ready, go. We've already gone.
Desperate straits. Ooh.
I messed up.
Uh-oh.
Don't mess up. Especially not for Indians.
Maybe.
Well, actually, that's
Might
not
have
true.
messed up. Maybe.
Is that what you got so far? Okay, where did you mess up?
That third line. Yep.
What did you mess up on? The left side or the right side?
Well,
Okay. Well, what did you do?
that's a good question.
Okay, well, do you understand what you should have done? This
Oh,
one's
I changed it.
identity.
Set of signs.
Well, that is, you would have had to go all the way to here before you did that, and you'd have this extra cosine hanging out, so you definitely don't want to do it that way. You definitely want to change the signs. Okay.
Now we can do +2 and find out what 2 equals 1.
Yes, now it's positive 1.
Yes.
Yes. Yes.
So it's.
And at 0, it's a 0.
So 0 pi divided by 2 pi. That's it.
At 1, it's a like pi.
I got it right. Let's go.
For some reason, their answers only gave pi and pi over 2.
What? Does it not count as 0?
Also, the instructions say between 0 and 2 pi, and I feel like there's a mistake in the key because I feel like this would be the complete answer based on the instructions. Because I think they accidentally poofed one of the signs or something. I don't know, or just left them off. Who knows? All right, homework set.
Homework. Really no one.
That doesn't even make sense.
What did you say?
I said homework. I barely know it.
Yeah, that doesn't even work, bro.
That does not look great.
It doesn't work at all.
Take home.
14 through 34 evens.
Who? 14 to 34.
And I think we'll wait to start the next lesson. I think that's totally fine. We're we're a titch early, but not too bad.
That was not a
What
noise
was
I'm
that?
not going to make again.
Zesty hot boys, that just hurt. Let's go. I guess go play golf. Have a good time.
Wait, play golf or work?
Gonna have a good time.
I'm actually off today. It's great.
That's crazy. That's awesome.
Cray cray.